here we have someone who is 25 years old, so they're 25 years old. We'll move that up. And they deposit initially $1,000. So this is the initial deposit is $1,000. And we'll move that up. And it goes into a traditional IRA, individual retirement account, for 45 years. So the time is 45 years. And then it says the interest rate is 4%. And of course, another way to write 4% is 0.04. I'll move that up. And it's compounded annually, and this person retires at the age of 70 years. Okay? So from 25 to 70 years. How much money will be in the account when the person retires? So the equation we're going to use is that the amount of money at any given time is the payment that this person makes on regular intervals multiplied by the fraction, where in the numerator we have 1 plus our interest rate, our APR, that's our interest rate, divided by N, where N is the number of payment periods per year. And this expression, and that expression is raised to the N times Y, where N is the number of payments per year, and Y is the number of years. And from this we subtract 1. And this is our numerator of a ratio. And in the denominator, we have our interest rate, APR, divided by the number of payments per year. So let's take this and move this up. Okay, so to do our calculation, the amount of money that we will have is equal to our payments that we make each year, and that's $1,000, or this person makes each year, so we have 1,000, times, okay, so we have in the numerator, we have 1 plus, well, our APR, our interest rate, is 0.04, and in the denominator, we have N. Here's our N, and N is the number of deposits per year. We make only one, or this person makes one, $1,000 deposit. So a 1 goes down here. And this is raised to the N times Y. N is 1, and Y is the number of years. And the number of years is the difference between 70 and 25. 70 minus 25 is 45. So it's N is 1, Y is 45. 1 times 45 is 45. So this is raised to the 45. And then we subtract 1. Then we have in the denominator, we have the APR divided by N. The APR is 0.04 and N is 1 payment per year. So it's 0.04 divided by 1. And that works out to be, let's see, the amount is equal to $1,000 times, now when we have 1 in the denominator of a fraction, and we have this in two places, the 1 can just go away. So that's just like 1 plus 0.04 raised to the 45 minus 1 all over 0.04. And this is equal to 1,000 times, well, 1 plus 0.04 is 1.04 raised to the 45 minus 1, and this is over 0.04. And now we can just plug this into our calculator. And when we plug into our calculator, what we can do is we can say 1,000 times, left parenthesis, we want to close it because what we want to do is this entire expression we want enclosed in a parenthesis. So we do that, there's the first parenthesis, and now we say the numerator is going to be, I have to do 3 parentheses, 1.04 close parenthesis raised to the 45, we're raising it to the 45, and we're going to close that parenthesis. So what we have here is from this parenthesis to here is this expression right here. It's 1.04 raised to the 45. Then we subtract 1 minus 1, and we close that. And so what we have now, from here to here, see we have 3 parentheses here, and 1, 2, 3 to the right. We have 3 left parentheses, and we have 1, 2, 3 right parentheses. So this represents the numerator of this expression. So now we can divide this by, and I'll put this in parentheses, 0.04. And when we put this in, this should give us our answer. In this next problem, we're comparing the amount of money that people save over time. And we start with Yolanda, and she deposits $100. She starts with $100. And she puts in $100 per month in an account with an APR of 3%, 0.03. Then we have Zach, who deposits $1,200 at the end of each year, and his APR is also 3%. Let's move this up. Now the difference is that Yolanda, she puts in the $100 monthly, every month. And Zach puts in $1,200 every year. So for this problem, we're going to use the same formula where the amount of money for each individual is equal to the payment that this person makes times raised to the n times y minus 1 over the APR divided by n. So let's start with Yolanda right here to figure out how much money she has at any given time, or at time 8 years. So at 8 years, the amount of money that she will have is equal to the payment, which is $100, and that goes in monthly, times, okay, in the numerator we have 1 plus the interest rate, which is 0.03 divided by n, and in this case, since she's depositing monthly, n is 12 times per year, and then this is raised to the n times y, which is 12 times the number of years. N is 12, the number of years is 8, and from this we subtract 1, and let's put a brace around this because this is the entire numerator, and we divide this by another fraction, which is the interest rate divided by n, which is 12. So this is, after 10 years, how much money Yolanda will have. And I should put a bracket around this. And now over here, we'll look at Zach. The amount of money he will have after 8 years is, well, he puts $1,200 in per year times the ratio. In the numerator, it's 1 plus the rate, same rate, 0.03, but he puts his payments in only once per year, so n is 1, and that's raised to the n times y, n is 1, the number of years is 8, and we subtract 1 from that, so there's our numerator. And in the denominator, we have the interest rate, 0.03, divided by n, the number of deposits per year, and that's 1. So continue these two problems the same way we calculated the problem on the previous slide. And you'll have the amount of money that both Yolanda and Zachary have after 8 years.